Alright, so continuing on with Unit 4.3, like getting more into exponential functions and their transformations. Like we want to be able to graph. And we're not going to graph using a table. We're going to graph using, like I said, the actual transformation. So you'll notice that hopefully this looks really familiar to you, because in the past, we've looked really closely at equations where we had, like in a quadratic. So like in a quadratic, we utilize the equation y is equal to a x minus h squared plus k. And so we talked about how the a value would reflect us over the x-axis if it was negative, how the a value would cause a vertical shrink if we were a fraction, or how the a value would cause a vertical stretch if it was greater than 1. We talked about how the number inside the parentheses moved us left or right. And it was opposite though, remember that? So if it was x minus 2, it didn't go to the left, it went to the right. And then for the k, that was a vertical shift that moved us up and down. So we've already used this, we've already done this several times right here and applied this on the last test. And so now we're bringing that same concept into exponential. So you can see the color coding is the same, the chart's exactly the same. So if you dialed these in the last test, then this is like straightforward for you. You're just rolling forward with this process. What we want you to visualize is that when we talked about quadratics, when we compare with a quadratic, we compared and said that we knew we had a parent function. And that parent function was y equals x squared. And that parent function was this function that came down to 0 and basically had this common behavior. And then from there, we would take a point and we would move that point to transform this graph. So if we'd shift it left, right, or left, or up or down, and then we did some vertical shrink and vertical stretch. But we had the parent. So what this guy is that this is my parent. This is what the parent function of an exponential function looks like. It has this behavior. The graph comes from negative infinity. It cruises along what we call right here this special line, and I'm going to go ahead and grab some of my colors here and add on to this picture a touch. We have this special line right here, and that special line is called an asymptote, right? So here we are. So we have this horizontal asymptote at y equals 0. Remember, an asymptote is something that you get really, really, really close to, but you never touch. So in this case here, the behavior of my graph is that I'm never going to go below 0. I'm never going to get below that y equals 0 line. I'm never going to become a negative y. Well, let's think about that for a second. If I grab my graphing calculator, I go to y equals, and I just plug in a basic exponential function, like 2 raised to the x power. So that's a basic exponential function. It meets the requirement where I have a base and I have an exponent, and my exponent is my variable, my thing that's going to change. So I graph it to see what it looks like. So I've got that parent function, and then I go to the table to try to consider what's really going on here. So what I want you to see is this. No matter what value that I plug in for x, my y values never become negative. I just keep getting closer and closer and closer and closer to 0. And what I want to remind you right here is what's going on. This is scientific notation. So when I get to that spot right there where I have at negative 14, so I'm out here at negative 14 maybe on the x-axis, what that's saying is that my y value is 6 times 10 to the negative 5th, which is essentially 6, and then I go 1, 2, 3, 4, 5. So it's 0.00006. So this is science class concept here. This is that science class concept, is that we keep getting closer and closer and closer and closer to this spot, but we're never going to cross it. And that's the definition of an asymptote. When we come in the other way, our numbers grow extremely quickly because this is exponential growth. This is your science class. This is your physical science in middle school and high school. We talk about things growing really quickly, so exponentially. and just continues on from here. So we have a basic conversation, like one of the conversations that we're going to have consistently about each one of these topics when we graph is the domain and range. Well, my domain, and this is very, very uncommon for us to say, my domain for an exponential function will always be all real numbers, negative infinity to positive infinity. My range will be tied to my asymptote. So wherever my asymptote is on my graph, wherever this graph comes down and levels out, that's where my asymptote will be. That asymptote will help me establish where my range starts. So notice in my range here, I don't start at 0. I don't include 0 and go to infinity. I'm not saying that I start at 0 and go to infinity. I'm saying that I get really close to 0 and then go to infinity. So there's a key difference there. You know, in the past, we've actually included 0. So big change here. All right, so domain and range. Now, what does that mean for us when we graph these as far as looking at the characteristics? So here are a few problems right here. So based upon your previous experience with transformations, what I'd like you to do is to take the parent, and I'd like you to say, okay, here's what I have. Go ahead and write these down and identify what type of transformation do you see? What type of transformation do you see from each one of these graphs? Okay, so hit pause, go ahead and fill those in, and then come on back in with us. So on the first one, we have right here, this would be my H value. Since it's negative, normally negative would move to the left, but remember it's opposite whenever we're inside the parentheses like this, so technically there are parentheses right there, but because it's in a superscript, that's why we don't have to put it in parentheses. So this would be a shift to the right 3 times. Okay, the next one, this is my K value. This is on the end, so this would be a shift up 3 times. All right, so then we come here and we look at this one and we say, okay, what would that be? And so we say, oh, that's the A value. So in this particular case, that's my A. And that means that my A is a -1. So essentially here, since my A is -1, then I come over here and I say, oh, well, if my A value is negative, I have a reflection over the x-axis. So this is a reflection over x-axis. Okay, we'll come back to this one just 1 second. Well, you know, let's kind of just think about that for a minute and see if we can see what it really is. But then what about this guy? Well, it says right here, it says that A is a fraction, but that's not my A value, that's my B. My A value would be right here. This would be my A. So this is actually my B right here. So what the correlation I want you to see is that these two guys right here are actually exactly the same. These are exactly the same statements. Because if I change the way this one looked, if I got rid of the negative exponent, this would become 1 over 2 to the x. Which I know right now you're like, well, that's not exactly the same, but it really is, because remember that we could rewrite this, well, better yet, this would become 1 over x over 2 to the x. And think about this, any number raised to the first power, sorry about that, any number raised to the power, so first power, so 2 to the first power is 1. 3 to the first power is 3. So any number that I raise to the first power is going to be, excuse me, I got it backwards. 1 raised to any power is going to be 1. 1 raised to any power is going to be 1. 1 raised to any power is going to be 1. So when we come back to our problem here and we're looking at 1 raised to a power, technically that's just going to be 1 over 2x. So you can see here that these two are exactly the same. So to be able to see what this one really is, because I haven't given you the directions over here as to what it is let's plug in our calculator. So let's go y equals. We've got our parent function. Like, it's fun to put our parent function there as a comparison. Remember, this is our parent. And now we type in what we have. So we can type in any form of these. So we could do 2 raised to the negative x. We could graph. And so what we're seeing is this is a reflection over the y-axis. We could come back out and we could change this one up, and we could do 1 over 2 to the x graph. See, it's exactly the same. We could do, let's see, the 1/2 one. So, we're kind of just stalling here. So we got open parentheses, 1 fraction 2 close raised to the x graph. So there's my parent function, and there's my negative, or the 1/2 to the x. Okay, so transformations with our graphs, there they are. Now that your job is going to be for each one of these is, once you have your graph, you need to talk about the domain and the range of them. And so let's go to the actual assignment to kind of see how that's going to work. All right, so take a preview here and make this big, change that to work, and then we'll finish up this video. All right, so when you come into the homework problem, this is what it's going to look like. And you're going to have this option. It's going to say, okay, I want you to graph this. So you click on this guy to graph it. You choose, let me change something on my window just real quick. See if I can, that way when I make it big, it's bigger. That's a little bit better. Okay, so you're going to choose your graph. So if you're not really sure, you can hover over. It'll tell you x squared. It'll tell you at some point, it'll tell you logarithmic, so you can see that that's exponential. So you click on your exponential tool. You just click anywhere on the graph. So it's not that you have to click at 0, 0 or 1, 0. You just click someplace. And then you get this command box that pops up. So what we have to say to ourselves is that this particular graph has a +3 on the end. The +3 is going to move us up or down. So we come over here and we say, we don't have a vertical stretch, we don't have a horizontal stretch, we have a vertical shift. And we have a vertical shift up 3 times. So we slide that guy over to 3. If you have any other transformations that you think it has, you can put it in. You save, you check, and there's your answer. Now it's going to ask you for the domain. So now we take a look at the graph. You can make it bigger if you want so you can see it. But now they're going to ask you for the domain. Well, I already told you that the domain for all of these exponential functions is going to be -infinity to +infinity. Oops. Didn't take. There we go. Check. All right, then they're asking for the range. Well, now you look at this graph, and what we see about this graph right now is that it has an asymptote. My asymptote is at 3, because you can see this graph comes down and cruises along at y = 3. You never go below 3. You can verify this, and I'm getting a little wordy here, and you don't have to do all of this. I'm just trying to seal the deal for you. I'm trying to get you to see that this is truly what's going to happen here. So we can type it in our calculator so that you can see, and I can show you once again what that asymptote looks like. So we hit graph, and we already know what it's going to look like. All right, so we go to our table, and remember, this is what I wanted you to see, is that you can see when I'm in the negatives here, on this negative portion of the graph, so out here at -6, -7, -8, it says it's touching 3. It's not. That's just because your calculator can't go any further. It has no more decimal places here, so it just goes to 3. The reality is that you never get to 3. You never touch it, which tells you you have an asymptote. If you have an asymptote at 3, then that means that your range, in this case, starts at 3. Doesn't include 3, so notice I didn't use a closed parentheses. I used the open parentheses on that, and then we can check our answer. Okay, same thing if we go scoot forward one more. Get to 1. There you're just getting graphs, so you can do it with your graphing calculator, do it with your graphing calculator, choose the graph. Right here, here's another transformation, tell the domain and range. This guy has 2 transformations. So when you put this one in, you'll have a left-right transformation, in and up and down. But none of these are going to have the vertical shrink or stretch. So when you do these guys, none of them are going to have a vertical stretch or a horizontal stretch. Okay, you're going to be looking at vertical shrink or vertical stretch, vertical shift or horizontal shift. All right, so let's wrap that video up with that right there. Let me hit pause just for 1 second and make sure we're good to go. Yep, that wraps us up. So this is a little bit lengthy, so do your best to watch it through, practice the problems, and use it as needed.